Howdy. In this video what we're going to do is we're going to talk about how to find the volume of a parallelepiped. Now this is my best attempt at drawing what a parallelepiped. It's a three-dimensional parallelogram. Okay, it's not the prettiest of pictures, but I'm hoping you get the idea. You have a parallelogram and then it basically extends out in 3D. Now what you're going to need, okay, is you're going to need 4 points. First off, you need 3 points to actually make this parallelogram. Then you need one more point in order to actually make it three-dimensional. So let's call this point right here A, B, C, and D. What you're going to do is you now need to find 3 vectors. And this vector needs to basically span from the same point. So the vector from A to B, let's call this vector right here. I'll call that vector A. Then the vector from A to C, we'll call that vector B. Okay, and that's going to create your parallelogram out in 3 dimensions. This will be our vector C. And given those 3 vectors, the way that you find the volume of a parallelepiped, your volume is going to be A dotted with B cross C. Okay, so let's go ahead and take a look at this example right here. What's going to happen is it says, what is the volume of the parallelepiped spanned by AB, AC, and AD, where these are your following 4 points. Now once again, please, please, please don't cross these points. These are points, not vectors. What we need to do is find the vector AB, find the vector AC, find the vector AD, and we can call that vector A, vector B, vector C. You can call it whatever you want. You could call it vector happy face, sad face, and triangle for all I care about. But as long as you find these 3 vectors, then we can go ahead and do that. So let's find my vector AB. Remember, a vector from one point to another, tip minus tail. So my x-coordinate, 1 minus 1 is 0. For my y, -2 minus a -1 is -1. And then 3 minus 1 is 2. For my vector AC, okay, tip minus tail. And if you don't know what I'm talking about, tip minus tail, finding a vector from one point to another, check out the vector algebra video. It's the first thing I talk about. So if you don't know what I'm doing, go check that out real quick. And if you do, let's just keep on going. AC is -2 minus 1, so it's -3. And then for the y, -3 minus a -1 is a -2. And then 1 minus 1 is just 0. Finally, the vector AD, it's again tip minus tail. 2 minus 1 is 1. -5 minus a -1 is -4. And 3 minus 1 is 2. Cool. And now that I have these 3 vectors, we'll call that vector A. Let's call this vector B. Let's call this vector C. I'll kind of show you a little shortcut as to how to find A dotted with B cross C in one quick step. The way you're going to do that, if I want to do A dotted with B cross with C, instead of writing I, J, K at the top, you're actually going to write your vector A at the top. Your vector A is 0, -1, 2. Then you just do B and C just like you would with a normal cross product. And so you write your vector B, it's -3, -2, 0. And you write your vector C, that's 1, -4, 2. Okay. Now I'm still going to insert that template like I do for most cross products, except I'm replacing I, J, and K with 0, -1, and 2. Okay, and notice I don't even have to do this one because anything times 0, heck, all that's just 0, so I can completely ignore that. So that's pretty cool. So let's figure out what goes in this middle one. Well, if you remember, cover up that column and cross multiply. -3 times 2 is -6. -1 times 0 is 0. And then here for my 2 or this would normally be my k parentheses. You cover up that third column and then cross multiply again. Negative 3 and negative 4, that's 12. 1 times a negative 2, say negative 2. And so this is going to be, okay, so check this one. This is minus a negative 6, that's plus 6, times a negative 1, it's minus 6. And then here, 12 plus 2 is 14, and 14 times 2 is 28. So your final answer is 22. Okay, so for these three-dimensional parallelograms, all you need to do is find those three vectors, and then A dotted with B cross C, you put your vector A in the first row, vector B in the second row, vector C in the third row, and then just do your cross product like normal, except instead of writing I, J, K at the top, or on the sides, you replace it with your vector A. And that's it. That's how you find the volume of a parallelepiped.